Thank you.
So we move on in the workshop. So we are going to start with the panel discussion.
No, you can say.
So the panel discussion is going to be chaired by Professor Tobias Mattisson. And we have also a new speaker that is Dr. Abad. So just a few words about both. Professor Tobias Mattisson is a full professor in the energy technology, space, earth, and environment at Chalmers University in Göteborg, Sweden. And he's an expert and one of the pioneers in the development of chemical looping technology. And obviously, he has extensive knowledge about fluid beds, oxygen carriers, materials, chemistry, kinetics, etc. He has participated in mostly all the projects related with the development of chemical looping technology in Europe for more than 25 years. And yeah, it's very good friends of this, all of us. So yeah, good morning, Tobias.
Good morning.
Dr. Alberto Abad is a senior researcher at our group, Combustion and Gasification Group at Instituto de Carboquímica of CSIC in Zaragoza. His focus in the development also in chemical looping technology, but especially he has long experience in the development or testing new oxygen carriers, the design and operation of continuous pilot plants, as well as the process modeling and techno-economic assessment. So thank you very much for attending to this panel. And Tobias, you are the chair of the panel discussion, so whenever you want.
Yes, okay, thank you. Thank you very much. And I would like to thank Daofeng and all of the members at CSIC for involving me in these workshops. And I think it has been quite interesting speeches here. So, and I would say rather broad perspectives from more specific tests with CLG from Daofeng. To a more overview of gasification processes by Professor Chow. And Ivana had some thoughts about the problems or maybe opportunities with respect to ash composition of microalgae and more dirty fuels. And Sylvia also had another perspective about other conversion technologies for microalgae. So I think that this gives a very broad base about the microalgae and gasification and other conversion technologies, which I think is reasonable because the project, which is the base for this, the Marie Curie, has not been continued so long, so that it's early in the process. So with that, I would like to encourage everybody here now. We are a little bit behind schedule, but maybe we can draw if needed a bit after 12. I think that may be okay. But we should maybe aim at 20 minutes or so. So we have the speakers in the panel and also Dr. Abad. But I would also like to encourage people, if you have any questions to the panel, please put those in the chat and we will try to pick up on those for the speakers. If there's for one speaker or all the speakers, please enter your questions into the chat, and me and Xiaoyun, who's here, will try to forward these to the panel. But maybe I would like to just take a broader view of this topic, and maybe ask all of the panelists about their view on where the main challenges. I mean, microalgae. I heard about this first a few months ago, but maybe I would like to ask where you see the main challenges with respect to use of microalgae. That is, like, where do you see the most maybe the problems in the whole value chain, and where would you, from your perspective, see that you really need to have research in order to get this fuel or technology off the ground? So maybe then we take it in the maybe we start with Daofeng then.
Yeah. Yes, yeah, I can start. So thanks, Tobias, and thank you for chairing this panel discussion. Yeah, I always, because I'm going to use microalgae, so I always think positive part of this field and opportunities. But now you want me to say something about challenges. So it's a challenge itself. But yeah, as you mentioned, that microalgae is I mean, some speakers already talk a lot about microalgae. And but the microalgae are high alkaline biomass, as you said, Tobias. It's like a dirty fuel. It has ash. That ash probably have a lot of potassium, sodium, and maybe also phosphorus. So I mean, we have a lot of experience from Chalmers and also CSSC that use biomasses. The biomasses has this kind of alkalis in the ash. So that means we have experience on sodium and potassium with regard to chemical looping gasification with different biomasses. But I think microalgae, it's what is the difference between microalgae and other biomass fuels? Is the microalgae, it has a kind of bit higher phosphorus, but we didn't touch much about the phosphorus based on our current tests. And I mean, we don't have experience on phosphorus, but we are going to study this microalgae. So I mean, probably phosphorus could be one challenge. It could cause problems with the oxygen carrier activity and further. Maybe I don't know. I think maybe Ivana knows more about the. I'm sure Ivana knows more about the thermodynamics aspects, but could cause agglomeration and maybe some other issues related to the oxygen carriers. And I think maybe this is one thing we need to think about to maybe to scale up this CLG for biofuel generation by using microalgae as a fuel. This is one thing that I think maybe we can discuss more about this. But I think it could be a challenge. Yeah, another thing that the microalgae, the cultivation of microalgae, it depends on the regions. So for example, in Sweden, I guess it's quite cold now, so maybe it's not suitable for the growth of microalgae. So, but here in Spain, it's still quite warm, and microalgae can grow. So I think microalgae can be a seasonal biomass. So it depends on regions, and maybe also this could cause some different interesting regions for use of this fuel. And I mean, it can be a regional technique, but yeah, I mean, this of course it's a lot will be a bigger scale. That's what I'm thinking. Yeah, I think this is the 2 points that I thought could be interesting and could be, if you have more thoughts about this, and we can probably discuss.
Okay, thank you. Yeah, I think those are very are two good points. But one thing I was with the ashes, but do you foresee that you will? I mean, it's very high moisture content, but so how would you see that you would, if you're going to use chemical looping, how would you like, what type of, I mean, moisture content, and how would the material look like when you feed it into a reactor, do you think?
You mean the content of moisture?
I mean, you have to dry this, I assume, before you use it, but also how would you, I mean, I'm not sure the form of this, but would you not need to make particles of this before you use it
Yeah,
in the chemical looping?
I think moisture could be a problem before the fuel gets into the reactor, because based on on my batch reactor test, and also we had started some preliminary test with the continuous unit. And so before the fuel enters to the reactor, the hot zone in the reactor, it can already partially gasified or like decomposed. And this, I'm not sure if the moisture will favor or help the devolatilization or like a partial gasification, but we got some like a sticky tar or something like a tar before before the fuel enters to the reactor. So I thought that the moisture may be one reason, but so we try to make to dry the microalgae before we feed to the system. Still, we have problem with the. By the way, we use the particles like in the size of 200 to 400 microns, and we have this problem. And now we are looking for another way, like to get pellets from the microalgae. But I think we need to dry the microalgae as dry as dry as possible before we send to the system.
Okay, so then we continue with the next speaker. Again, I remind maybe Professor Ming Chao again about how your speech was more general, but with a lot of experience on gasification. So maybe you could give your view on how you see like main challenges with respect to microalgae and where research is maybe needed.
Okay. Thank you, Chair, Professor Mattisson. I think it's a very good question. So according to my talk, I think you can see I do not have lots of experience in macroalgae feedstock for the gasification, but I do have some ideas about that. So actually, our pilot scale plant was located aside Taihu Lake. I think it's one of the biggest lake of China. The macroalgae I have experienced was not cultivated by people. Actually, it was harvested from the Taihu Lake. You know, the lake is very big, and according to the pollution recently, is lots of algae, and you know, the local government has organized lots of investment to get algae out of the lake. And for maybe many big cities like Suzhou, Wuxi, and Changzhou, they have very big pressure to deal with the the algae waste. So actually, people will say, okay, algae could be used for high value product yield like protein, like feeding stuff. But unfortunately, the algae waste from the Taihu Lake will be having lots of toxicity, and it will prevent the use for feeding stuff or maybe for the fertilizer things. So we have to use algae as fuels. So just as Professor Mattisson mentioned, the moisture content is too high. I think it's one of the biggest challenge for the gasification. So actually, we require the moisture content less than 20% for the pellet. Normally, 10%. So we have to dry the material, using quite a high energy input. Another thing is the algae, the dry content of the algae is quite little. It's not too much, right? So actually, if we want to set up a gasification plant, we need maybe at least several hundred tons of dry material. So I don't think the algae dry content is sufficient for the gasification skill. So these two problem could be solved by the combination of algae with other biomass. So that is what we have done. From the agriculture, we can get lots of the waste, biomass waste, and they have very little moisture content and quite a high heating value. And we can mix the half-dried macroalgae together with the the agricultural waste or maybe forestry waste, and it is quite easy to make the pellets. So by making the pellets, so we can avoid the challenge of just now I mentioned the algae amount is not enough, but by adding the biomass, it could be enough. So that is why I mentioned in my slides, for the gasification, we'd better to combine different source of the biomass waste, and then we can satisfy the feeding requirement of gasification, and we can also solve the environmental problems. This is the moisture challenge. Another challenge is ash content. Just now, Dr. May has mentioned the low, the high alkaline metals in the ash of macroalgae. But actually, if we mix macroalgae together with the cellulosic biomass, so because lots of woody biomass has quite high magnesium and calcium content, so that if we combine them, the alkaline metal content is not a problem. So actually, to my experience, the fusion points of my feedstock is in most cases more than 13 or 1400 degrees Celsius. So in my fixed bed reactor, so actually the maximum temperature is 1200, and we didn't see noticeable slagging problems. So the ash content is no more problem if we combine more biomass into macro algae. Another benefit is we found quite a number of sulfur content in the macroalgae. In the water gas shift reaction, so currently many catalysts like cobalt series catalysts need the syngas has some sulfur content because the catalyst will be activated by sulfur content. So if the biomass doesn't offer enough sufficient of sulfur, the catalyst won't be working well. So if we add the macro algae into the woody biomass, the algae will offer additional sulfur content into the pellet, and the syngas will have sufficient sulfur content to support the downstream water gas shift reaction. So that is why, to conclude, I think the future solution to address the challenge of macroalgae waste is to combine algae with other woody biomass, and we can deal with more sources of waste, and we can more stably convert the solid waste into useful fuels and high value fuels. Yeah, that's my idea.
Okay, thank you very much, Professor Zhao, and that's very interesting. So co-firing as an option, and with respect to the moisture content, perhaps also very good heat integration in the plant, depending on what you do. But also, as Daofeng said, ash could be an issue. Maybe it depends a bit. Your technology is a bit different, of course, than chemical looping, with higher temperatures. But so maybe the ash is different. But then I will just with respect to time, then I will go to the ash expert here in this crowd, Ivana. So maybe you can elaborate on how you see the main challenges with respect to microalgae.
Thank you. Yes, I think the major challenges has been brought up both by Daofeng and Professor Zhao Ming. So ash, of course, I talked a lot about the alkali contents, and I think from a ash chemistry point of view, this is a particularly interesting fuel because we are usually dealing with fuels that have a lot of silicone in it that usually causes the biggest problems. And here we don't have that, but on the other hand, we have a lot of phosphorus. So I think that's very interesting. I think one of the major challenges would be to avoid, on one hand, avoid the release of the alkali metals to the gas to avoid corrosion. And on the other hand, capture it in the bed without causing these type of problems, the agglomeration problems. And I think also like to investigate the catalytic effect of potassium and sodium compounds in these type of conditions, because I think there are some potential for synergies keeping the metals in the oxygen carriers and also using their catalytic effects. That's possible. Also considering phosphorus, we have seen that in other applications, usually it ends up coating our particles. So it should be, in theory, very available for us as it sits on the surface. So I think also it would be really interesting and probably also a challenge to look into the fate of phosphorus and how, possible extraction methods for it. I think that could be interesting and challenging as well.
Okay, thank you very much. So, again, very much related to ash content. Something we can discuss a lot more, I have a feeling. But considering we're a little bit tight on time here, I will go on to the last speaker, Sylvia. You had another perspective on other conversion technologies, but maybe you can give us some perspectives on where you see from your point of view the main challenges with respect to use of a microalgae.
Hello, Tobias.
Hello.
Well, I agree with all the opinions and comments of the rest of the speaker. But to summarize the general challenges of the use of the microalgae to obtain biofuels, we think and we take on account that we need sustainable fuels from CO2. In the case of the third generation biofuels from microalgae or algae, there are several technical challenges to be more sustainable economically, environmentally, and energetically. There are three main points, in my opinion. First, the efficient and the cost-effective capture of the CO2 by algae. We need more productivity of lipids to extract this lipid to produce biofuels. For this reason, I think it's necessary to work in the adaptive evolution of the algae. And to increase the production of lipids. The second point I think is very important, the optimizing treatment process of algae biomass, because currently is a problem the water, especially in the microalgae. The process like the watering and drying of the algae are treating very expensive and have a problem in the next steps in the conversion of the process of the products. And in my opinion, the first point important is the efficient and stable catalytic conversion processes for biofuel synthesis. I think these 3 points are crucial for a large scale success. And in our case, the raw material cost has no importance, but we need to consider the cost of the green hydrogen needed for the conversion processes. And of course, we also have to compete with other sustainable fuels in terms of price and availability. Well, this all. Thank you.
Yeah, thank you very much. Yeah, and I think that the last one was is key, that you really need a cost-effective fuel, and there are of course a lot of other bioresidues, but the availability may be not questionable. But you have a lot of forest and agricultural in certain regions of the world, which may be also a feedstock, of course. But I will then thank the speakers, and now I will continue with the last member of our panel, and that's Dr. Alberto Abad. And Alberto, if you could give maybe your views on the main challenges with respect to use of microalgae and microalgae in CLG.
Yeah, thank you, Tobias. Yeah. First, thanks again to all speakers for the nice presentation. It's very, very interesting, different points of view from different fields. So it's good to hear all of you. And in this case, in the framework of the project, of course, one challenge is how the ash affects to the process. Okay, we have to evaluate the fate of all the elements in the ash compounds. Some a fraction may be evolved in gases. So in the gas treatment, the gas cleaning, it should be considered not only the tars, maybe also we must consider the cleaning of other compounds. Tars, of course, may be a main product, but also may be found other elements that can affect to the downstream, like sodium or chlorine, or even ammonia. Okay, and the fraction of ash that remain in solids, of course, may interact chemically with the oxygen carrier compounds. In this case, if the oxygen carrier has a negative effect, for example, on agglomeration or deactivation, this would be a problem. But in some cases, it has observed that the oxygen carrier can absorb some elements from acids, but it was not found a negative effect. In this case, how much? The question is how much is possible for an oxygen carrier to admit an amount of a certain compound. You are talking about sodium, potassium, silica, or phosphorus. Okay, but also we have to consider if there are particles that from us that remain in the bed mixed with the oxygen carrier particles, and this ash should be removed. Okay. This is what happened when we try to test, for example, swine manure in chemical looping. This is a residue for the pig farming, okay, and it has a high amount of ash, and up to 30% of ash. The problem here that the accumulation of ash particles in the bed, not the interaction, not the chemical interaction with the oxygen carrier, but the main problem was its accumulation in the bed. This forced to have a pure stream from the bed, and the oxygen carrier is lost. You will have to supply fresh oxygen carrier quite often to the bed. And this is also a problem when we consider the ash accumulation in the bed. But of course, chemical looping has many advantages to process microalgae. For example, in chemical looping gasification, not only syngas is produced, also CO2, and CO2 should be separated from syngas, and then it's possible to be used for the microalgae farming, for example, or for to produce e-fuels with electrolytic hydrogen. And in the case we need more CO2, in this case, we can perform also a chemical looping combustion of microalgae. In this case, we can obtain a purified stream of CO2. And also, I forgot this, in chemical looping gasification, it's possible to obtain from the other reactor a nitrogen stream. And this nitrogen stream may be integrated with hydrogen to produce ammonia as energy storage material product. So the chemical looping has a lot of possibilities to be integrated with microalgae processing.
Okay, thank you very much, Alberto. So I think, yeah, you pointed out some very interesting advantages with the chemical looping and dirty fuels and microalgae specifically. And that I think is quite important. And well, you're preaching to the choir here, but of course I agree with all of these advantages, and I think that can be very interesting to see how this performs in the future, and how Daofeng's experiments in the coming months and year work out. So now we are beyond time here, and for many, not in Spain, of course, but in many other parts of the world, there's lunch, maybe like here in Sweden. But maybe we will maybe can pick up one question from the chat, I think.
Yes, we have one question from Nasrin Nemati. Her question is, what are the constraints or limiting factors influencing the growth conditions of microalgae, and what the specific conditions are required for their large-scale cultivation? Are there any large-scale microalgae cultivation projects currently operating worldwide? So I'm guessing this goes to Silva or...
Yeah. So yeah, so this was it's in the chat, I believe, but it has to do with it's a very interesting question about cultivation, if there are limiting nutrients, or if you need enzymes or any type of fertilizers, and also if there are any current large-scale microalgae production plants in the world. So is there any speaker which would like to take this very interesting question? Is there anybody who has any information about the production of microalgae and nutrients needed, or also if there are any any current large-scale production facilities or plans for this?
Professor Tobias, I don't know expertise in microalgae. I expertise in the production of biofuels, but I think it's a very interesting question. Perhaps the main problem is the nutrients to grow the algae. And I think to choose or select the microalgae or algae specific to the production of lipids or carbohydrates or proteins. But I think the main problem is to choose the specific nutrient for each kind of microalgae selected.
Okay, thank you.
In my opinion.
Yeah. I think it could be very, also with respect to resources and also how the local and regional environment. I mean, you don't want to solve one problem and create another, but I don't know this so well, so I don't know. But okay, so I think that considering we are about 10 to 15 minutes late here, I think I will conclude the panel discussion, and I would like to thank the panelists. And I would like to again, and it was very interesting, and I learned a lot, and maybe Xiaoyun also. Yeah, you learned a lot.
Yes,
Yeah,
yes.
Xiaoyun, I mean, we learned a lot.
Whole message in the chat is from For Blue Tech, and they said, as per your recent question, we at For Blue Tech we do offer our facilities for growing microalgae.
Okay, very good. So there's in the chat there is a link, I think. Yeah.
It's like a message from For Blue Tech. I think it's a company.
There's a company who involved with the production of microalgae. So it's in the chat, so people can, I think, take a look at that. So that's great. So then I will give the word back to Paco to finish up the session.
Yeah. Thank you very much, Tobias, for sharing this panel discussion. I mean, I think this has been an interesting talk. Maybe we should talk more about, but maybe in the future, about more the technologies to process the microalgae, because we have speak a lot about microalgae production, but not so many about the different processes that we can use to produce biodiesel or biofuel. I mean, the different routes for biofuels production, thermochemical or biochemical. But this is, I think, that is an idea that we can continue in the second workshop that we are thinking to do next year, and hopefully we can present some of the results that we are getting in the Marie Curie action of the of May. So just to close the workshop, I want to thank all the presenters and also the attendants for the participation in this first workshop related with the use of microalgae for the third generation biofuel production. After finish this workshop, I'm quite optimistic because I see a lot of things that are arising about microalgae use for biofuel production. It's true that we need to do something, and the use of biofuel is very nice to have it, and probably it has a lot of experience in the last year. So we have speak about different challenges, microalgae production, several processes, several routes, but as I told you, probably we can talk more in the second edition of this workshop. So just to conclude, thank you very much for all the attendance to this meeting. We conclude here this workshop. Have a nice day, and I hopefully see you next year. Thank you very much.
Thank you, everyone.
Thank you.
Thank you. Thank you very much.
Take care.
Thank you. Thank you. Bye-bye.
Bye-bye.
Bye.
Thank you. Bye.
Bye.